Okay, so another related rates problem. This time we have water draining from a funnel. And so you're given a picture that you have this funnel in here. And you have water that is pouring out of there. Water is draining from the bottom of the cone-shaped funnel at a rate of, so it's draining at a rate of 0.03 cubic feet per second. It tells us what the height of the funnel is. The height of the funnel is 2 feet. So we're given that this in here, this height is 2 feet. And it's given this radius at the top of the funnel. And the radius is given that it is 1 foot. Okay, so knowing that, it wants us to answer the following question. At what rate is the height of the water in the funnel changing? When the height is a half a foot. Okay, so the water is draining out. We need to know when this height here, we want to know it is a half a foot. So a couple of things that we need to know. We need to know what the volume of a cone. Okay, I don't know what that is. I just have to pull that up, which I have right here. The volume of a cone is equal to, and so I would give you this on an exam. I'd give you this formula. I don't expect you to have this one memorized. Is 1/3 pi r squared times h. The thing is that we have volume, we have the radius, and we have the height. So let's think about this. Can we change this? We want to find the rate of change of this height. So we want to see, can we rewrite the radius in terms of height? And if you think about it, this cone can be thought of like as a triangle. And so here we have R. And here we have H. Ratio of sides, similar triangles. So R over H. I can do this as it's another similar triangle. I don't know what R is, but I do know what this height is, right? At this height here was 1/2. Okay. Did that help me? So let's solve for R in this case. So if we solve for R, so sorry. Let's do it this way. We know R over H. We know these values in here. This here is 2, and this here is 1. So our R value is 1. This is 2. Our height is 2. And so I want to solve for my height in terms of, actually, I want to solve for R in terms of H. So if I multiply both sides by H, I get R is equal to 1/2 times H. Okay, so let's go back in there and let's substitute so that our equation is all in terms of H. So if I do that, I have V is equal to 1/3 pi times R, but R is 1/2 H, and I'm going to square that times H. So just clean it up a little bit before we take the derivative. So we have V is equal to, if I square 1/2, I get 1/4. You can think of it as 1/4 times this 1/3 out here. So it would be a 1/12. I still have this pi. And then I would have an H squared times an H. So that would be an H cubed. So now let's take the derivative of both sides. So dV dt, the rate of change of our volume, is equal to 1 pi 12ths. And then taking the derivative of H cubed, we get 3H squared times the derivative of H with respect to time, dH dt. We're trying to find this change of the height. So we're trying to find dH dt at this height. We know what it's draining. This is the rate it's draining at. So we know what dV dt is. It's 0.03 cubic feet per second. So we're going to start plugging in things. We're actually trying to find dH dt, so maybe we could get that by itself first and then plug in. So I notice 3 and 12, 3 goes into 12 4 times. I could multiply both sides of my equation to get dH dt by itself by the reciprocal. So how about multiplying by 4 all over pi h squared? So we would get this dH dt is equal to, 4's cancel, our pi and h squared cancels, equal to 4 all over pi h squared times dv dt. And we're just going to go in there now and plug in what we have. So we got 4 all over pi times our height. Our height, that's 1/2. Squared times dv dt. And dv dt is 0.03. So we just need to simplify this down. But you need a calculator. This height is changing, this height is shrinking. So I need to think about this too. It's draining. This should have been a negative in here. Negative. I'm looking for my calculator. So if we look at 4 times negative 0.03, and we're going to divide that whole thing. I need parentheses around this whole thing. Pi times 1/2 quantity squared is 1/4. So pi times 1/4. And that denominator, yeah, that's the denominator. So I get that this is negative approximately 0.153. And it's going down in feet. Our time is seconds.